turbocharged and turbo normalized?
It's basically how it's set up. So it's all essentially the same type of components. You've got a turbocharger that takes the ambient air and compresses it and then puts it into the engine. How much of that you put into the engine is what really determines whether it's turbocharged or normalized. So if you take like a Bonanza, for example, in order to take at the time, 285 horsepower engine in a Bonanza and make 300 horsepower out of it, they turned up the manifold pressure to above ambient pressure. So,
and the only way to do that's with some sort of compression system.
Some sort of compression system. Now, because they didn't have an intercooler and the cylinders tend to run hot and you had detonation problems, they reduced the compression ratio even further. So if you took the turbocharged system off, it would only put, out 250 or 60.
They lower the compression.
Right. So then they had to boost the manifold pressure even further. So that makes 36 inches of manifold pressure to make 300 horsepower, 36 and a half. In a turbo normalized system, you keep the same 8.5 to 1 or higher compression pistons, and so it's still a 300 horsepower engine with or without the turbo system. But you limit the amount of manifold pressure that you can make. You normalize it, so to speak, to sea level performance.
Okay. So you're not boosting up so much farther past ambient pressure.
Right.
It kind of normalizes. It keeps it the same.
Yeah, and you are depending on how high you go, but for sea level, it's normalized.
And that's controlled via wastegate. How do they normalize?
It's an automatic wastegate.
Automatic wastegates. Okay.
So it's 30 inches to take off at 20,000 feet. It's
still 30.
Yeah.
And explain this electronic mag. That's super intriguing.
This is a future product of ours.
Is it approved?
No, it's a future product.
So it's not approved yet.
Right.
But I really am intrigued with it.
Well, the main thing with it is it uses these internal cylinder pressure sensors.
Oh, and cool. Look at this, Dave.
Some special spark plugs that we had made
special, we didn't notice that, the little special adapters on those plugs.
Yeah, so you take these out and...
that is super cool. When do you think that'll be ready?
Oh, I don't know. It's got a lot of technical challenges. I mean, it works really well in the test cell, but the parts are not readily available. They're laboratory equipment, laboratory grade parts. So they're not.
That is the coolest thing I've seen in a while.
So the internal cylinder pressure sensor comes
it's got a
out.
probe. So it's a pressure, not temp.
Right.
Pressure sensor.
And it measures internal cylinder pressure. And then it adjusts the timing accordingly.
Does that have some O-rings on it?
Oh, it's got a little crush gasket, which is not present here, but there's a little copper gasket.
Not screwed in, it's just pushed in?
No, it's screwed in.
Oh, is it?
It's threaded, yeah. A pressure sensor, that's amazing. So, and that goes in conjunction with this mag.
Right. And there's different versions that could use, one of these on the cylinders we know are the most likely to have detonation problems. There's, versions of this that don't have to have any of this. If it's on all 6 cylinders, then you can.
I like this idea here, Dave. This grommet to help the wires. I actually purchased some of those yesterday. These grommets.
80 clamps.
Yeah.
Well, thank you.
Thank you.
So as a lot of you already know, we did the big transformation between the mass electrode spark plug and the fine wire spark plug. We're here with Champion, and one of the experts can maybe explain it a little bit more in detail than we could.
Howdy everybody, this is James Seps, Champion Aerospace, based in Liberty, South Carolina. Still proudly made in America 100%. And today we're going to show you our massive and our fine wire plugs.
Awesome.
Some cool things to check out here is here's your standard massive electrode plug. You've got your center electrode and your ground electrodes. These plugs have been around for over 50 years. They're great. They last around 500 hours when properly maintained and gapped and cleaned. They're a great plug, that's why we still make them. They meet the demands for a lot of pilots. And I tell people, if you're flying 50, 100 hours a year, this is 5-10 years of lifespan. That's plenty for most folks. If you're flying at that level, this is a great option. If you want the cream of the crop or the tip of the top, we've got fine wire Iridium spark plugs. The main difference between these two plugs, you can see, is the much smaller ground and center electrodes. These are made out of iridium, a rare earth metal that's a byproduct of nickel manufacturing and mining. This iridium is very robust and holds up very well to heat and other fouling. You can see here on our chart, when you have lead fouling, carbon fouling, or oil fouling, this plug has much less surface area than the standard massive style. It prevents those deposits from being inflated there as well. These plugs last anywhere from 1,800 to 2,000 hours if you maintain them properly, and they're much lower maintenance due to the robustness of the material. They don't need to be regrabbed as frequently. Make sure you're using proper procedures in cleaning them, and if you take good care of them, they'll take good care of you. It's a great product, and we're really proud to offer it.
What are the proper procedures in cleaning them? Where can we find that technique?
Certainly. So at championaerospace.com is a great resource to use to look up all of that. We have our application guides, manuals, and other procedures on there as well. The most important thing is to use a bench tester, is what I tell everyone. You can test the plugs there. You can also clean it. They use a glass bead aggregate to clean it that's soft enough so it doesn't damage the ceramic, but robust enough to clean off any carbon deposits or lead fouling.
So carbon and lead get built up, not just lead.
So it depends. So depending on your mixture procedures in your engine, how you fly, if there's any blow-by in the cylinders that's occurring that can lead to oil depositing, how hot your CHTs get, all those things can contribute to different kinds of fouling on plugs. So
and this is cool. You can pretty much match the plug up to the chart by.
Certainly.
That's an amazing.
Yeah,
wow.
That's our intent. So it gives you a good idea of the lifespan, life cycle of your engine, how it's performing, and it's also a great way to look at pilot procedures. One thing I tell people is if you run excessively rich, obviously lead fouling is more likely to occur. Also, the cylinder's keeping cold, it's not getting hot enough to melt off that lead. So this is a great way to kind of see what your habits are doing, what your engine's doing, and it's a great way to see the health of your plug.
Wow, thanks for the quick explanation. That's very important.
Thank you.
Thanks everybody, and thanks for flying Champion.
Oh, you're slick too. Are they,
Oh, honey.
I just saw
So we just
oil
purchased your
filters.
So we just found out that Champion is also doing slick magnetos. So we're going to talk to Dan about the slick magnetos that we just changed on the right engine.
Champion again. Here what we're showing off is our Surestart system. But before we get to that, I'd like to go over basic magneto operation. First and foremost, I'd like to show you at really low RPM, there's not enough velocity being generated in that rotor to create sparks. You have to pick up speed. You'll see here it'll fire normal. You can go fast enough, you can even get the wide gap to hit it. What we have here is our Surestart ignition booster. The Surestart connects to your starter solenoid, a power source, and into the P lead of the magneto so it can energize the coil. When it's engaged, even at extremely low RPMs, it'll generate 340% of standard spark energy. Wow! So this is great for hot starts, cold starts, or if you have student pilots that are really hard on starters, this will save you a bundle on having those rebuilt. It starts a lot more like a car. The story I tell everyone is I fly a 421 Bravo with a buddy of mine. Those are geared turbocharged engines. On a hot day flying that thing, go get a hamburger and come back and it's still hard to turn over. You put these on there, it starts up like a car. They're STC for anything with a slick or Bendix mag. They retail around $1,200 and can be bought through distribution. It's a great product. It works for about 99% of things flying out there. The other benefit of this mounts through the firewall. With solid state electronics in here, it's very durable. We have people flying with it for over 10 years. So when you get a new engine, you get new mags, this ignition booster is still there in the firewall ready to be hooked up. It does a great job. Another advantage I like to get into, this might be more at the IA or mechanic level, is a lot of you guys will have an impulse coupled magneto. What an impulse coupling does is it has these pawls here that engage on a stop pin. As you continue to crank or hand prop, you continue to rotate, there's a spring in here, and that's where you get the excess velocity required to get the spark generation like we discussed earlier. If you've been around magnetos, if anything's going to fail on it, the highest likelihood item is the impulse coupling. A great benefit of the Surestart system is you can replace your impulse coupled magneto with a retard breaker magneto. Reason being you need the retard breakers has two sets of points, one at TDC for low RPM and one at base timing. This impulse coupling not only adds the additional velocity, it also retards the ignition to TDC for startup. So it's a great advantage. It gets your highest failure rate item off of your magneto. It's great for starting. The only downside of that would be is if you have a dead battery on the ground, your plane won't start. But I'd rather be on the ground with a plane that won't start than in the air with an impulse coupling that's failing.
Just when I thought I knew a little bit about the system, I realized I don't hardly know anything about it.
Yeah, it's super
Thanks.
interesting. Yeah, and so, a lot of people don't know why. Why is your magneto timed at 22 degrees advance? What's that all about? So what I like to explain to people is if you ever ridden a bicycle when you're a kid, if you crank that bicycle pedal a few degrees off of the top dead center and you go down, you get good velocity, that good power stroke,
Better
right?
momentum.
And then what happens is as it drifts further down, you're getting less and less. Your magneto is designed because it's on fixed timing by the engine manufacturer to produce peak pressure in the cylinder during takeoff procedures. So we have full mixture and full throttle. That's when your magnetos get the most out of your engine. So when you're in regular flight and cruise speeds, you're getting partial strokes in that pedal because these things are timed to have that maximum output. So if you ever wondered why that timing is important on your engine, there it is. Wow. So the reason you use magnetos still is because they have onboard power generation. A lot of these electronic ignition systems out there rely on a battery bus, and if the battery goes dead, there is no spark being generated. The magneto makes its own power through the rotation. As we were talking about earlier, it needs a certain amount of RPM to generate that power, but once that's achieved, your engine keeps running. That's why if your batteries die, your avionics stack goes down, your engine keeps running. So that's why magneto is a great system. Been around for a long time for a reason, and onboard power generation is critical for a flight safety item.
How long has this product been around, your Surestart?
The Surestart used to be called the Slick Start. We replaced some subcomponents in it about 2 years ago, rebranded it the Surestart, but it's been around for over 10 years. Like I said, STC for just about anything that flies, Slick or Binix Mag. It takes your A&P about an hour to install if you've never done it, 30, 45 minutes if you got experience.
Now, I'm wondering why we haven't heard about that before, because I like buying tidbits for the plane, and
it's a great upgrade. They come from the factory on SR-20s. Cherish uses them a lot, and that's a training aircraft. And like I said, anyone that has student pilots or low-hour pilots flying, they know how expensive it is to replace a starter. This is a great way to circumvent some of that.
Cool. Thank
My
you.
airplane is
Thank you again.
hybrid.
Yeah, the Aeroshell team uses these products, so you know they must be top notch.
Let me show you the RV where we're staying during sun and fun. It's my parents' RV. It's enough space for Eric and I. Little kitchen, fridge, a lot of storage, TV, which we're not using, table. We have a portable AC because the AC on the RV is not working right now. Gotta figure that out, but that's saving our lives right now because it's pretty hot. Pretty hot. And the bedroom. Again, lots of storage. And the bathroom with shower and toilet. So very lucky to have that as a base camp. Pretty awesome.